REST introduction. Here, the topics we are going to cover include what is and why you want to use REST. And we'll talk about the principles of RESTful architecture. And then we'll talk about REST is everywhere. That means every services that you find on the net are in the form of REST. So we'll actually do a little bit of exercise going through some of the well-known websites for accessing the services that are exposed in the form of RESTful services. I will talk a little bit on REST versus SOAP. Right now, most of the organizations are using REST instead of SOAP because SOAP is pretty complicated. And then we'll talk about JAX-RS, which is the Java specification for building and deploying and accessing RESTful services. And we'll talk about some of the tools, mostly client-side tools. What is and why REST? Before REST was introduced, there were many different communication standards and protocols, starting with RMI on Java community and SOAP, CORBA, and DCOM on Microsoft World. And these protocols and standards, well, I wouldn't say that they are standards, but these are introduced by many different parties. Sun Microsystems has RMI because Sun is the one that introduced Java, and Microsoft introduced DCOM, and IBM and a bunch of other companies had their own communication protocols. Now, having these many different communication standards and protocols caused interoperability problem. Organizations were not able to interoperate. And it is hard to implement, and obviously some protocols, some standards are from a particular vendor, so you have a risk of vendor lock-in. So all these problems are caused by having multiple communication standards and protocols. So that is where REST comes in. REST stands for Representational State Transfer. And the concept was introduced by Roy Fielding and in his doctoral thesis called Architectural Styles and Design of Network-Based Software Architecture. It's pretty kind of complicated thesis title, but what he tried to address the following. If you actually see, the web has been incredibly successful. But what he tried to actually figure out is that why can't we use the success of the web for building and deploying applications? Okay? So basically, why is and web so prevalent and pervasive, and what makes the web scale? And his question was, how can I apply the architecture of the web to the applications? So he found some of these architecture styles that make web so successful and pervasive and scalable, and he wanted to apply the same architecture styles for, again, development and deployment and usage of applications. And that's basically what REST is all about. REST is for development and deployment and usage of applications, taking advantage of the same principles of the web. So the benefits of REST, I meant, basically from deployment standpoint, it could allow you to build and deploy scalable applications, high performance, loosely coupled, and fault tolerant, and secure and interoperable. So these are the benefits from a deployment standpoint. From a developer standpoint, it is simple and intuitive and consistent. So if you have actually built any SOAP applications, or if you have worked on CORBA in the past, you probably know how complicated it is to build those applications. Building RESTful applications are very simple, and as you are going to see, basically, we're going to use a few annotations and boom, you have RESTful applications. It's friendly to developer. Again, it's very intuitive and very simple to build RESTful applications. It's programming language independent, meaning you can use any programming language to build and access RESTful applications. And in fact, most languages have REST support. In our case, we are going to use Java, and Java community has what is called the JAX-RS, which is the REST APIs. It's basically a set of annotations that you can use to build RESTful applications in a declarative fashion. It's very simple to use those annotations. And it's explorable via HTTP tool. So basically, RESTful applications can be exposed through the HTTP protocol, as we are going to see later on. So you can just use any HTTP tools to access the RESTful services. Moving forward. What are the architectural principles that make RESTful applications RESTful? These are the set of architectural principles of REST. First, addressability. Second, uniform interface. Third, representation oriented. Fourth, stateless. And fifth, HATEOAS, which stands for hypermedia as the engine of the application state, and cacheable. So we'll talk about each of these principles in a bit more detail in the following slide. Addressability. What that means is that every resource has unique address in the form of URI. If you remember, if you actually see how we actually use the web, basically we go to a particular resource using the URI, right? Same deal in REST. Everything is in a form of a resource, and every resource has a unique URI address. URI structure is something that we are very familiar with, basically HTTP or HTTPS, and then you have a host and port number, and you specify the path, and you can have a set of query parameters. And characters that are allowed in building a URI addressing is A to Z, capital or small letters, numbers, and a dot and dash and star and underscore. And other characters get encoded. Space is encoded to plus, and others are encoded to percent and the character, to XX characters. And each resource has a unique URI, and basically it enables resource linking, and that's basically what HATEOAS is all about. These links can be embedded into document, and the links embedded in the document carry also states. And we'll talk about this HATEOAS concept in a bit more detail when we cover that topic later on. Uniform interface. So HTTP has a set of methods, and each of which has a specific purpose and predefined behavior. I mean, this behavior is specified in HTTP specification. So those methods include get, put, delete, post. Those are four methods we are going to use the most, and it also has what is called the head, patch, and options. And these methods have a concept of safety and idempotency. Safe methods are HTTP methods that do not modify resources. So nothing is modified on the server side when you are using safe methods. An idempotent HTTP method is a method that can be called many times without different outcomes. So idempotent HTTP method always should return the same response. Now we are going to talk about which method is safe method and which method is idempotent method in the following slide. Now the benefits of using this uniform interface includes simplicity. So compared to CORBA and compared to SOAP, there is no need for IDEA-like contract. So basically, it's basically sending HTTP request to a URL resource, and that's it. Easy accessibility. Client does not need any special library or stuff. Like in SOAP, you have to basically using WSTL as a contract, and you have to create a stub by using a tool. And in REST, you don't need to do any of those. Basically, all you need is HTTP client library in order to send HTTP request. Interoperability, so due to simple requirements, meaning we are basically using a small number of methods, HTTP methods, the interoperability is almost guaranteed. So REST clients and REST services are highly interoperable because simply there are less moving parts. Scalability, you can take advantage of a built-in caching capability of HTTP. Now, by using REST, you can build CRUD applications, CRUD-based applications, real easy. By the way, the CRUD stands for Create, Read, Update, and Delete. Okay? Now, these CRUD-based operations are performed through a combination of HTTP method and URI pattern. So, for creating a brand new item, the first one, you are going to typically use post HTTP method and HTTP the noun. Basically, the URI pattern will be collection URI. So if you want to create a new song, it's going to be post request, and the URI is going to be, let's say, Beatles/songs, and then you are going to obviously send the newly created item in the post body of HTTP request. Read multiple. If you want to read multiple items, then you're going to use get, and the URI pattern is going to be collection. So if you want to read all Beatles songs, then it's going to be get, and then the URI pattern is going to be Beatles/songs. If you want to read a single item, then you are going to use a get HTTP method, and then the URI pattern is going to be entry URI. So if you want to read number 3 of Beatles songs, then it's going to be get, and URI pattern is going to be Beatles/songs/3, something like that. And update a single item, you're going to use put or patch, and then again you're going to use entry URI. So if you want to update song number 3 of Beatles, is going to be Beatles/songs/3, and obviously you have to actually have the content that will be used to update the song number 3 in the body of HTTP request. By the way, the difference between put and patch is that put, you have to actually send the complete contents of that item, while patch, you can send just the portion that need to be updated. Delete is simple, so you use the delete HTTP method, and you're going to specify entry URI. So if you want to delete song number 3 of Beatles, you're going to send delete HTTP method, and URI pattern is going to be again entry URI pattern, which is a Beatles/songs/3. Okay, so representation oriented, again, this is another characteristic of RESTful services. What that means is that each service or resource is addressable through a specific URI, and representations are exchanged between client and server. So these representations are typically in the form of, let's say, XML or JSON. So with get, you get current representation of the resource, and with put or post or patch, you pass a representation of a resource to the server so that underlying resource state can change. So put is for update, and post is for creating a new resource item. The representation has self-descriptive message. What that means is that the document you are sending back and forth between client and server should contain complete information. So it's self-contained or self-descriptive. Stateless communication. So what does that mean? It does not mean that your RESTful applications can't have a client state. It could, and it should in some cases, most of the applications in fact. It means is the server does not maintain the client session data. Instead, when client session need to be maintained, the client session state should be coming from the client. So client is the one that maintains the client state, and every time we communicate with a RESTful application, client send the client state. So server does not need to maintain client session data. And obviously it has the benefit, scalability, simply because the server does not maintain the client session. And reliability as well, because the server does not actually duplicate the session data, client session data, in case of server crash. Okay? So the scalability means that you can just add a server without being concerned about the maintaining or duplicating client session data, because client is the one that always send the client session state. HATEOAS, again, it stands for hypermedia as the engine of the application state. If you think about the way we as human beings use the web, basically we go to the website and we get the response page, and response page contains a bunch of links, and we human beings just click those links to move to the next state, right? So we are going to use the same thing in RESTful applications. So it enables document-centric approach with embedded links. So basically when the response is sent back to the client, the response should contain the links so that the client can actually follow the link. And again, we're going to actually talk about the benefits of this, embedded links in a bit more detail later on. And each document has so basically each document that is returned guides the client to other resources. Again, we as human beings, when we are accessing the website, those links are in fact giving us a clues in terms of what comes next and what could be actually useful moving forward, right? It's the same deal. So these documents that are returned from the server should have links so that client can actually go to the appropriate links to move forward. Cacheable response messages from the service to its consumers, meaning clients, can be cacheable or non-cacheable. I mean, this is based on HTTP caching protocol, and basically in the RESTful services you can actually control this HTTP caching behavior using APIs. The service, the contents that can be cacheable in many different locations. It could be cacheable on the client side. It could be cacheable in the proxy. It could be cacheable even on the server side. Okay, any questions up to this point? So we just talked about the concept of REST, and we talked about the principles of REST and the benefits of REST. Any questions? Okay, so if there are no questions, let's move on to REST is everywhere. So pretty much all services out there on the net are exposed as RESTful services. Basically all these big companies, Amazon, Google, Facebook, Twitter, LinkedIn, you name it, pretty much all these big companies, big internet organizations have some services they could actually expose. For example, Google Map is a great service. People can actually access to find the information about the particular location, right? And all those things could be actually exposed as RESTful services. The way we actually use these websites, Amazon.com, Google, and Facebook, and Twitter, and LinkedIn, we humans actually use this website by actually going to their website, right? And they send back this information in the form of HTML. Now, in RESTful environment, basically the client is not a human being. Client is, in fact, an application. And applications do not care about the look and feel of HTML. They want to receive, they want to actually access these services as, the non-human client. Typically, they want to receive the data in the form of JSON or XML. So all these companies expose their services and data in the form of RESTful services. There is in fact the website called the programmableweb.com. This is the website actually collects all REST APIs for pretty much all companies, all organizations on the net. So if you want to find out typical APIs, RESTful APIs that are exposed by a particular company, you can actually go to this website and actually find out, and you can actually kind of play around as well. Okay, so we are going to do our first hands-on lab. For those of you who have attended JPassion.com code camp, you probably know the drill. You go to the website and you download the zip file into your location. So I have done that already. And once you have the zip file downloaded, I have already have all this zip file on the labs. Okay, and you are going to unzip the zip file. The first one we are going to unzip is 4361 Java REST Introduction. So you can use any unzip utility of your choice. If you have a JDK, you can use a jar command. So you can say jar xvf and name of the zip file, and it will create Java REST Introduction directory, and they have index.html file, and that is basically lab documentation. So let's actually open the lab documentation. So I'm going to go to the labs and Java REST Introduction and click index. So that is a lab documentation. We're going to actually do exercise 2. So exercise 2, we are going to explore REST APIs on the net. Okay, so click the exercise 2. The first, internet REST services is a Google APIs, Google Maps basically. So if you click this link, you're basically getting the location information about the Chicago. So it has the address information, geometry information, and I guess that's about it. And if you want to actually change the location, you can certainly change your location of your city. So I'm going to use maybe New York City, and it will give me the information about that New York City. And if I want to have maybe LA, and this LA is basically short name of Laos, not Los Angeles. So I guess if I want to get the Los Angeles, I probably have to say the whole Los Angeles, something like that. Okay, now you can see here is receiving the data in the form of JSON. So this is the this is where you can actually change the format. So if I want to receive the data in the form of XML, then I'm going to just say XML and get the data, and you see the information is being sent back in the form of XML. Okay, so this is a pretty simple exercise. All right, and that's actually 2.1. I'm going to give you guys about a few minutes to try these things out. And then we are going to actually go to this programmableweb.com. So as I talked about during the presentation a few minutes ago, this is a great website where you can find out all APIs exposed by pretty much all organizations out there. So if you the API directory, you can see on the left side, you have a Facebook, Yahoo Weather, Google Maps, AccuWeather, and all those things. So you can actually filter based on category or protocol or more recent. And most of this, by the way, these websites actually require you to get the secret key first. Okay? So for example, if you want to communicate with a Twitter, you cannot just communicate with the Twitter website unless that website, the service is actually kind of really public. But most of these organizations require you to actually sign up, basically as a developer to get the secret key and all that stuff. There is actually one website like here weather. This is the weather services, and let's actually click here weather, and you are going to actually see here weather here, and this website lets you actually access their web services using demo secret key. Okay, so here typically all these companies have API endpoint, homepage, primary category and all this information. It does even have interactive console URL so that you can actually play around. So I'm gonna just click this interactive console URL. Okay. And in this case, basically they give you a bunch of information, and it does in fact let you. So this is the URL, okay? And again, this is the getting the weather information of the Chicago, okay? And they let you in fact use application ID, which is actually signed for you, which is a demo, and this is a secret key. So these are typically what you have to actually acquire before using any of these internet services. But here we're gonna just use this default application ID and the application code, okay, that is provided for the playing around purpose. So now we are going to send the request, and you can see that this is the result. This is the information about the weather information about the Chicago. The city is Chicago, okay. And obviously, if you want to, if you want to go different cities, so I'm gonna go to Boston maybe, and again send the request, and then you're going to get the information about the Boston. You can actually play around with other, let's say you can actually have hourly forecast. So actually let's get the hourly forecast of Chicago, and send the request, and then we have okay, so did I send it? Okay, so now we got the hourly weather data on Chicago. Okay, so you can just play around with these things, and so let's see the traffic. You can actually get the traffic. So let's say traffic map maybe. So let's actually get the traffic map, and again this is the let's see. Oh, so here this is the zoom column row. Okay, so let's actually see. Let's get the let's actually send the request, and we got some response. Let's see. This is the zoom column row. Yeah, so this is some of the information in terms of zoom column row, and let's see what is the location information. City, newest normal data. Yeah, there must be some way that you can specify the let's actually try to traffic map. I expect the some kind of the location information. Oh, looks like it's a current location. Yeah, let's actually find. I cannot actually find the location information specified in this traffic map. But you got the point in terms of the what about the map image? So default map image. Oh, this is map image on the specified location. So here you specify the location, and oh, I guess this is in terms of the coordinates. And let's see if there is any other way that you can specify. Bounding address with the address. Yeah, so basically all this the services are exposed as a RESTful services. Yeah, so this is actually based on coordination, and I think there is actually a website that you can actually how about the map image with the address. So address is Britain and 17, and the location, yeah, so this is the address seems like. Okay, so again, if you actually send the request, and you get some responses. So in the exercise, I want you in fact play around. I mean, you can certainly take a look at the other APIs. So go to, let's say, Google Maps. Okay, you can Google Maps, and basically it gives you a bunch of information. This is the API endpoint, and you can see this is a version 1 homepage, and let's see if interactive console URL. Okay, so it might not actually require the application ID or secret key. So yeah, and a bunch of information, and Oh, so yeah, Google has a lot of actually RESTful services, right? Okay. All right, so the idea is that I want you to actually get exposed to some of these readily available RESTful services out there, and then actually play around with it. Okay. Okay, so I'll give you guys about the 10 minutes for exercise 2. I'm giving you 10 minutes because this might be the first time you actually are working with a JPassion.com hands-on lab. Okay. All right. Let me. REST versus SOAP. SOAP is losing its actually popularity during the past, I would say, 10 years because its complexity. So SOAP-based web services, the paradigm is that there are few URIs but many custom methods. For example, get recordings is one of the custom methods that needs to be specified in the contract in the form of WSDL. It uses HTTP as a transport, meaning HTTP is one of the transport protocols that could be supported, that could be used, even though in many cases in the SOAP web services, 99% of the time they use HTTP. But they could use SMTP or they could use JMS if they want to. On the other hand, the RESTful web services, HTTP is the protocol, okay? So you cannot use anything else. The paradigm in RESTful web services that there are many resources. They are in the form of URI. I mean, they are addressable in the form of a URI, and they are resources. And few fixed method, meaning we are talking about just HTTP method: get, post, delete, and put. SOAP-based web services are about services. For example, stack code service and RESTful web services are basically we are talking about in the concept of a resource, and resources can be manipulated by exchanging representations. So SOAP-based web services, you are basically talking about accessing procedures, while RESTful web services, we are talking about accessing resources. And communication is done by exchanging this document in RESTful web services, and those documents are in the form of XML or typically JSON. Advantages of SOAP over REST. Transport independence. If that's important to you, then you might want to actually choose SOAP, but in most cases you're talking about HTTP as a protocol in many, even in SOAP-based web services. SOAP has a well-defined standards in the area of transaction, security, reliability, and things like that. While in REST, we are basically talking about SSL as the protocol, the security schemes. Okay? And SSL has served us very well on the web during the past, let's say, 30 years. So, same SSL could be actually used for securing communications on RESTful services. SOAP has a well-defined service contract called WSDL. REST, you don't really need it because basically you can specify this is the URL that you actually start accessing the services. However, REST community came up with what is called WADL, which is the documentation specifying the list of services, list of RESTful services that are available on that website. Advantages of REST over SOAP is, again, simplicity. It's very simple in terms of developing RESTful applications and also deploying RESTful applications. REST works with many different representations, XML, JSON, and XHTML, HTML, while SOAP is mainly talking about XML as the only choice as a representation. Okay, so let's move on. JAX-RS. JAX-RS is basically Java standard for building and deploying and accessing RESTful services or RESTful applications. Now, before JAX-RS, you can certainly actually provide RESTful services using standard Servlet API, but you have to write a lot of code. This is actually kind of code that you have to write. Too much coding, too much boilerplate code you have to actually write yourself, and obviously that's not desirable. So that's the reason JAX-RS was born, to allow you to build RESTful applications using a few declarative programming style annotations. Okay? So it should support RESTful concepts such as everything is a resource and should be addressable via in the form of URI, and HTTP method provide uniform interface and representations of formats of the data, and again HATEOAS. So the JAX-RS, the goal of JAX-RS to support this basic fundamental REST principles or concepts, and also support high-level and declarative programming model. So basically let you use annotations to make your services resources RESTful services. Okay, generate or hide boilerplate code. So there is no need to write the boilerplate code yourself. Basically those boilerplate code is actually created by the system for you. Okay, JAX-RS is a standard, so there are in fact multiple implementations, and the reference implementation is called Jersey. That is a code name, and it comes with a bunch of servers, Glassfish, and Java EE6 plus servers. And there are other implementations of JAX-RS. Apache CXF is another example, and JBoss has what is called the REST Easy and RESTless. So these are different implementations of JAX-RS specification. We are going to actually use Jersey, and you're welcome to actually use the different the implementations if you want. Your program still should work as it is, because these guys are all using standard JAX-RS specifications. So regardless of the choice of the underlying platform, your application should be portable. In terms of tools, so we're going to use IDE for building RESTful web services applications. We're going to actually use Eclipse, but any IDE of your choice, as long as that IDE supports Maven, which is the case for Eclipse, IntelliJ IDEA, NetBeans, any IDE can be used. For client-side tools, we are going to mostly use curl, which is command line tool, but you can use Postman, which is the Chrome applications. REST client is the Java applications. It gives you kind of GUI front end, while the curl is actually command line. There is also what is called the SOAP UI. This lets you in fact perform some kind of over the performance and performance testing and things like that. We're going to mostly using curl to access the web services, and of course you can use a browser. Browser is typically used to access the resources, but it's not possible to change the server-side state. For example, the update, for example, is rather difficult. Even though you can have a form, that could be used to change and create a new items. Okay? But here we're going to mostly use browser to access the services using get. Okay, so exercise 1 is tools. So if you see the lab documentation, let's see, lab documentation. Yeah, I'm gonna just open the lab documentation here one more time. And exercise 1 is basically download and install curl. So if you are using macOS and Linux, the curl should be already available. If you are on Windows platform, you have to go this website and download curl. So you can just download the curl from this website, and yeah, so you go to download, and you're gonna actually get the zip file and unzip it, and then curl is available. So once you have downloaded and unzip it, and you should be able to use a curl command. So make sure that you can actually use curl like this, and it should give you some kind of help message. So if you have this kind of help message, that means curl is available. Postman is Chrome plugin, or you could actually install it as a desktop application. It's pretty actually comprehensive, so it's pretty powerful. Let's see if I have a Postman here. Yeah, so Postman, I have installed it as a desktop applications, and so yeah, so let me just move on. So yeah, so here you go. So I don't have any website here. I don't have any local RESTful services, but you can actually select the bunch of HTTP method. This is URL. You can specify the parameters. You can set the headers and things like that. Okay? You can even actually save this command. You can save this command so that you can actually later on pick the command that you have executed. Okay, so that is Postman. And REST client, this is again Java-based REST client tool. So I have provided this jar file, and once you have that jar file, and you can actually execute this jar command. So I'm gonna just run it, and you should be able to get the jar file. Oh, I have to actually go to some location where I have this jar files. So I'm gonna actually start the REST client. I have a batch file that actually go to the right location, on the REST client directory, and it's accessing the jar file, and again it's actually providing GUI front end. Okay, so you can select the HTTP method here. You can set the headers. You can work with the cookies. Body here, you specify the contents you want to send, authentication, and some of the SSL and things like that. Okay, so you can use, if you like GUI front end, you can use either Postman or REST client. Okay, all right. So if you're using, by the way, REST client, you might want to actually set the options to be set options and auto indent response body. If you don't do this, then XML response is going to be a single line rather than auto indented response body. So if you want to see the contents like this instead of a single XML, then you might want to set the options and then auto indent. So I think that's what I have. Okay, anyway, so that is a tool. So as long as you have a call installed, then we can actually move forward. Okay, so I'll give you guys about a few minutes to install call if you have not have call already installed.